Okay guys, so in this video I'm gonna show you how to run some Hello World projects on IsaacLab, meaning how to run like very simple template scripts that already comes with the IsaacLab project, just for you to see how it works, right? So as prerequisites, you want to make sure that you have been through all the steps from the previous videos, meaning you want to make sure that you have IsaacSim installed on your computer, that you have cloned the IsaacLab project from the NVIDIA GitHub, and that you have your Python environment created here with all the versions that were mentioned before, right? So here I'm inside the Anaconda prompt. I have activated my environment and I navigated to the IsaacLab folder, which is the GitHub project that we cloned before, right? So from here, it's pretty simple. Now, all you have to do is to input commands to run the scripts that already come with the IsaacLab project. And what this will do is that they will automatically open IsaacSim and then run the template projects, or rather the template tasks there, right? So the first batch of tasks that I'll run are simply simulation tasks. So what they do is they just open IsaacSim and then run some 3D simulation there for you to see it working, right? So I'm just gonna go on and copy here. We have the quadruped one, so um, it lives inside the script tutorials environments folder, and this is the Python script. So create quadruped base environment, and you want to run with the Python command before it, right? So as soon as you do it, IsaacSim will start. It has opened the window here, and then it will load the simulation. And it will render the assets, the quadruped robots here on the environment, right? So if you use your mouse, the right button, you can just navigate and look around and see it working, right? So this is a script that spawns a whole bunch of quadrupeds and make them walk on this environment. You see that their sensors are working here, but there's no learning, there's no reinforcement learning behind the scenes, right? So if you look at the CLI terminal here, there's really nothing showing. So this is really just a simulation on the 3D rendering engine here on IsaacSim, right? Um, and you can close it, or you can just hit Control C here, and it will stop the simulation. I'm gonna put a list of um, other demos that you can run. You can also do this one here, which is the human eye robot um, simulation. Again, this is just environment, movement, and sensor simulation. There's no learning happening on the background yet. Right? And this is inside the demos folder. Right, so again, I'll put the link to my GitHub tutorials where you can see the exact command or the path for the simulation that you can just simply like copy and paste on your terminal, and then it will open and run, right? So it's just a cool simulation for you to see like how IsaacSim works. But the real magic happens when you start running reinforcement learning, tasks behind it, right? So there is also a few template reinforcement learning tasks that already come inside the IsaacLab project that we cloned from GitHub, and they live inside the reinforcement learning folder, right? So um, if you go on the path scripts, reinforcement learning, there is a folder for each library, and then there is the training.py Python script, right? So what this training.py script does is it will call the task, it will open IsaacSim, it will call the reinforcement learning task repository that NVIDIA um, also maintains, which is a Gymnasium, and it will call this task Isaac Carpal v0, right? So as the name suggests, this is a reinforcement learning task, and here you can see the reinforcement learning workflow working behind the scenes, right? So together with all of this, one of the things that this script does is that it will also call reinforcement learning libraries and scripts, and then train the simulation, right? So if you go here on your terminal, you can see the reinforcement learning steps and epochs happening here with the reward results here, right? So it's calculating all the model performance, the reward, the loss, total time steps, episode termination time, and all of that, right? So, and then you're running 150 iterations, right? So this is actually using the simulation being rendered on IsaacSim to train a reinforcement learning pipeline, right? So here you can see IsaacSim and IsaacLab working in tandem, right? So IsaacSim is the 3D rendering software that renders all these carpal assets balancing on a physics environment here. And the IsaacLab is the reinforcement learning scripts running behind it, right? So IsaacLab is using the physics simulation managed by IsaacSim to learn and to calculate the loss and reward for the model, right? And I'll talk more about this on future videos, but it's based on the robot policies and the reinforcement learning reward function. It's calculating how precise the simulation is and how close it's getting to the objective, right? So here it's finished. It ran all the 150 iterations, and it calculated the reward, right? You can also run a ant simulation here, a quadruped simulation. Again, I'll post the command on the GitHub that I'll reference in this video, and provided that you have done the installation correctly, following the previous videos, you can see this RL simulation as well. So here it's opening IsaacSim. It is starting the rendering engine, and here you have like these ant robot models. As I said, again, IsaacSim is this platform responsible for simulating the physics, the environment, simulating when the ants tumble, what happens like when they touch the ground, if they jam. So it simulates a real physics world, and behind the scenes you have IsaacLab running the reinforcement learning simulation or workflow and calculating how close each one of these robots is to its movement objective. And based on how close or how far they are, it calculates a reward, teaches the reinforcement learning model so that on the next iteration they try to do better and get a better reward, right? So here you have like hundreds of little ants trying to learn how to move, and as the iterations progress, they get better and better at it, right? So on my next videos, I will show how to create your own external project and also run other tasks and simulations on that.